So welcome to Electronic Lab, and we are into the signal system lecture series. And today the topic of discussion is the causal versus the non-causal system. Okay? So what is the causal system? The output of the system at any instant n depends upon the present and past values of the input. Then the system is called the causal systems. If the output of the system depends upon the future value of the input, then it is a non-causal system. Okay. So let us check the details about the causal and non-causal systems. So as I have told you that the output of a system at any time t, that is y of n, it depends upon the present and past input values. That is, for example, x of n minus 1, these are the past input values. Okay. And x of n is the present input values, x of n minus 1, n minus 2, these are the past input values, but does not depend on the future inputs. That is x of n plus 1 and x of n plus 2 and so on and so forth. Okay. So if this happens, then it is a causal systems. Okay. For example, in mathematical terms, the output of a causal system, you can see it is a function of x of n. X of n is the present value of the input. Okay. So x of n is the present value of the input. X of n minus 1, these are the past values of the inputs. Okay. So this is the y of n. So output of a system, if it depends upon the present and the past values of the inputs, then it is called the causal system. Okay. So if the system is does not satisfy this condition, it is called the non-causal system. Means the output of a system that depends not only in the present and past input, if it depends also in the future inputs. Okay, that means x of n plus 2. Okay, or this is the y of n depends upon x of n plus 2. Okay, uh, so that is the future values of the input. So that is the system is called the non-causal system. Okay, so let us check with some examples. Okay, so determine if the system described by the following input output equations are causal or non-causal. So we will see, we'll one by one we'll check so whether these systems are causal system or non-causal systems. Okay, so you can see this is the first three. You can see these are the called the causal systems. Okay, so you can see these are the causal system because all the three cases the output depends upon the present and past values of the inputs. Okay, that is why these are called the causal systems. So you can see the system in 1, 2 and 3 are causal system because the output depends only on the past and present values of the input samples. Okay, so you can see over here. So these are the present values of the input sample. This is the past values of the input sample. Okay, so that is why the system is causal system. So you can see this is the you can check. Suppose n equal to 2. Okay, in this case, suppose n equal to 2. So it will be n of y of 2 is equal to summation of k is minus infinity to n x of k. Okay, to n, this is n x of k. Okay, minus infinity to n means it is 2, minus infinity 2. So if we put her here x of minus infinity, then x of so on so forth, it would be x of suppose minus 2 plus x of minus 1. Okay, plus x of 0 plus x of 1 plus x of 2. So you can see this is our y of 2. Okay, so here is n equal to 2. So you can see these are the past values of the input sample. These are all the past values of the input samples. Okay, and all are the past values of the input samples. Okay, because we are taking n equal to 2. So n equal to 2 means n equal to that is the minus infinity to 1. These are the past input sample, and this is x of 2 is the present input sample. Okay, present input sample. In this case, the output depends upon the present and past values of the inputs. That is why the system is the causal system. Here also a into x of n. So you can see if we put y of 1, that will be a into x of 1. So these are the present values of the input. Okay, this y of n it depends on the present value of the input. Okay, so y of 2 also, or a into x of 2. So that is means the present values of the input. Okay, so here is the n equal to 2, here also the n equal to 2. So these are the present values of the input. So in these cases, the output depends upon the present and past values of the inputs, not the future values of the inputs. That is why the systems are called the causal systems. Okay. let us see our this four cases. These are all the non-causal system. You can check. So the output depends upon the future value of the input sample. So you can see over here also. This is the x of n, x of n plus 4. You can see if we calculate y of 1, suppose, so this will be x of 1 plus 3 into x of 5. Okay, we can see this is the n value. So we are interested in the present and past values. Okay, so these are the present values of input, but in this case, this is the future values of the input samples. Okay, so that is why the system is a non-causal system. Okay, similarly, you can see x of n square. Okay, so if we check y of 1, that is x of 1. So it is depends upon the present values of this one. But if we take y of 2, so it will be x of 4. Okay, you can see this present value is of 2, but it depends upon the future value of the input samples. That is why the system is non-causal. In this case also, if we put y of 2, it will be x of 4. Okay, y in this case. Okay, so y of 1, it will be x of 2. So this is the future values of the input samples. You can see we are interested in find n equal to here 1. Okay, so this is the present values of the input, present value of y. So but if it depends upon the output, is depends upon the, you can see it is 2. So it is the future values of the input samples. Okay, so that is why these are all the means non-causal system. You can check over here. This is also y of n equal to x of minus n. Okay, so if we put y of here negative values, you are suppose you are putting y of 1, so it will be x of minus 1. That is this is that is means right. But if we put y of minus 1, it will be x of 1. So you can see this is the if we check this y at n equal to minus 1, the present value, the future x at n equal, this is 1. Okay, so it is the future values of the input samples. Okay, if we check at n equal to minus 1. So that is why these systems are called the non-causal systems. Okay, so you can see some the systems are non-causal since the output depends upon the future values of the inputs. Okay, so in last case also you can see, so it is also non-causal. For example, if n equal to minus 1, okay, here n equal to minus 1 if we put, so I have told you, so it will be y of minus 1, that will be x of 1. Okay, so that is the y of minus 1 if we put, that will be n equal to minus 1 depends on the input at n equal to 1. So it depends on the input at n equal to 1. So which is the 2 unit of time into the future. Okay, so we are into n equal to minus 1. So it is this x equal to 1 is the 2 unit into the future. Okay, so that is why the system is non-causal. Okay, so that is how you calculate whether the system is causal or non-causal. If the output of the system depends upon the present and past values of the input sample, then it is the causal system. If the output of the system depends upon the future values of input, that is the non-causal system. Okay. So thank you for watching this video. So if you have any doubt, you can free to ask me in the comment section. Thank you all. Have a nice day. Okay. Thank you.